A lot of the most profound insights and developments in blockchain arrive when somebody figures out that something we already know or are familiar with is actually just a specific example of something more generalized. One of those imaginative vaults was taken by Vitalik Buterin in 2013, and it helped redefine the very concept of a blockchain itself. He understood that even though we've been talking about a blockchain that runs a digital currency ledger, what we're really looking at is a specific application of a more general kind of decentralized data processing. What this blockchain does ultimately rests on the rules that are defined in this first step of our process here. But there is no inherent reason why these rules only and always have to be used to create a transaction or accounting system. Hey everyone, this video is sampled from my online course which teaches you tokenomics for fundraising. You'll learn about the fundraising process, key tokenomic concepts, and get a complete spreadsheet model that you'll learn how to use by solving real-world fundraising problems. You can find the link to the full course in the description section below. And if you'd like to support this channel and help me to create more free content, please like, share, subscribe, and hit that notification bell. That's all. Now back to the video. Hi everyone. So today we're going to look at smart contracts. Now there are lots of aspects to them, but from a business perspective, we'll see that they deliver value by helping us to automate economic agreements and business logic. And this is now the third lecture in this introductory series, Blockchain 101. So we have quite a bit to cover today. I try and make things as short as possible, but this topic is broad and multifaceted. It deserves to be understood from a number of angles in order for you to be able to understand and critically assess the value opportunities that this technology creates for business. We're going to start off by looking at how we take the digital currency blockchains that we looked at in the last lecture and turn them into a smart contract platform. We'll follow that with a look at some of the nuts and bolts of smart contract security, comparing the strengths and weaknesses of this new approach with more traditional approaches to application development. We'll then look at specific ways in which smart contracts can be used. Initially, we'll focus on how they solve contracting problems, but again, we're going to keep an eye on the requirements and limitations of this technology, as well as the opportunities they present. Finally, we'll finish up with a brief digest of some of the general implications that this technology has for business and startup economics in general. Okay, let's go. So last time, we explored centralized control as a feature of engineered systems. We looked at some of the benefits and drawbacks that this approach has for applications that make use of accounting ledgers. In particular, accounting ledgers that are used to handle currency assets for multiple unrelated parties. We then saw that blockchains give us an entire new way of decentralizing ledger control, which improves the security for these applications. We finished off by looking at the value add that decentralized digital currency ledgers could offer businesses and users. We saw that they could reduce reliance on external trust-building institutions, that they could unlock greater efficiencies for payments by making them faster, more secure, and removing the need for third-party middlemen. But we also noted that the size of this upside depended on the economic and institutional circumstances of each business, and that furthermore, attempts to capture this upside are frequently held back by regulatory or outright authoritarian challenges. This left us with an outlook that may have seemed less dramatic and revolutionary than I or others may have promised you. But you needn't worry, because this is the lecture where we're going to see that blockchain technology does deserve much of its hype, a view that I hope you will share once you come to understand the full power and capabilities of blockchain technology that are served up by smart contract platforms. Let's begin our journey by taking a fresh look at the digital currency blockchains that we've become familiar with and re-illustrate them as a sequence of distinct processes. First, a user submits a transaction request. The requests that users can make and how they're handled are first determined by a set of fixed rules that have been engineered for that blockchain. Those rules are basic or fundamental things like, does this user have a key to their wallet? Or does this wallet have enough tokens to fulfill the transaction request? And does the sender wallet address exist? The intended outcome of these rules is to create sound accounting for transactions of a digital token so that it preserves a defined finite quantity of that token and avoids double spending and other similar errors. Transactions that meet these basic requirements are then passed to the consensus process to check that it meets the other validity criteria to be included on the blockchain. Once the full block is validated by consensus, a cryptographic hash code uniquely chains it to the previous transaction block, and so the rest of the blockchain. This is the step that makes data commitments to the ledger cryptographically secure. Now let's pause here. A lot of the most profound insights and developments in blockchain arrive when somebody figures out that something we already know or are familiar with is actually just a specific example of something more generalized. One of those imaginative vaults was taken by Vitalik Buterin in 2013, and it helped redefine the very concept of a blockchain itself. He understood that even though we've been talking about a blockchain that runs a digital currency ledger, what we're really looking at is a specific application of a more general kind of decentralized data processing. What this blockchain does ultimately rests on the rules that are defined in this first step of our process here. But there is no inherent reason why these rules only and always have to be used to create a transaction or accounting system. We could create different rules that allow for different user interaction possibilities and create different sorts of control logic in our system. In fact, there are more uses and possibilities for this than could possibly be imagined by the core team of developers who first worked on the blockchain. So what Buterin proposed was to create a blockchain that allowed this part of our data processing sequence to be left open to be coded up as desired by third-party developers. The structure that was used to do this was called a smart contract. I know that's an intriguing term, but we'll come back to how it got its name later. Buterin then went further than this, proposing that the blockchain should be able to host multiple smart contracts at any given time and allow them to be able to talk with and interact with each other. Doing this would mean it would not be necessary to build a new blockchain every time you wanted to create a new application. And over time, you could use the other applications as building blocks to help you build more elaborate applications and services on that blockchain. Buterin's proposals finally became reality in 2015 when he and his team successfully created the first blockchain with these application development capabilities, Ethereum. Okay, let's put our skeptical hats on for a moment. We already have plenty of established and well-tested processes for application development that don't need blockchains at all. And they've been good enough to build all of the most successful applications of our day. So what on earth do we gain by linking open-ended code here to these mechanisms for decentralized data governance and state security on the right there? Isn't this just making everything unnecessarily complicated? Well, it certainly is more complicated, and it effectively makes up a new paradigm for application development, but the potential gains are huge. The promise of this architecture, when taken as a whole, is that it brings the same kind of security and decentralized governance guarantees to the execution of code that helped us manage those digital tokens honestly. Let's unpack this to see what I mean. Think back to the previous example in the last lecture. Remember, we discussed how a bank holds centralized control over this ATM service that it provides its deposit account clients. The rules that control that ATM service are just an example of a specific software application. So, in a more general frame, we could be talking about the owner and operator of any piece of software here. And we're now faced with similar concerns that relate to trust. We need to be able to trust that the owner of this application has not designed it to take advantage of us. And we also need to trust that hackers won't be able to break into these systems to abuse any levers of control that they offer. Here, as was the case with the bank, we rely on various external cultural, economic, and institutional factors to restrain and deter bad actor behavior in these situations. And since this looks so similar to what we've seen before, you may imagine that blockchain has similar benefits to offer as well. It gives us the chance to make certain abuses of control impossible to carry out in the first place, and to achieve that without having to rely on any of these external conditions or institutions. To see how this works in the smart contracts case, we'll have to look at some of the details of how smart contract platforms are designed, and that takes us on to the next topic for this lecture.